All right, so now we're going to do some movements with line segments, right? So consider the graph of the line segment whose endpoints are -1, +3, and 2, 0. Okay, so we have a line segment right there. -1, 3, and 2, 0. Graph the segment below. There we go. Change the x-coordinates to their opposites. So if the original x-coordinate was -1, what will the new x-coordinate be? 1. Keep the y-coordinate the same. And then do the same thing for the 2. Change it to -2 and 0. So where is this new segment going to be at? It's at 1, 3, and -2, 0. So it went like this. Okay, so how would you describe what happened here when I changed my x-coordinates to positives and negatives? It kind of flipped over which axis? The y-axis. Good. It did a flip, or what we call a reflection, over the y-axis. That's exactly right. Right? So if I changed my x-coordinates, it flipped over the y-axis. Well, what's going to happen if I change the y-coordinates? Now I'm just going to go back to the original and just change the y-coordinates. Yeah, so you guys can figure out pretty quickly. 2, 0 is still 2, 0, but -1, -3, it flips down this way. And so notice again, from my original orange segment to this new orange segment, it did flip again, or reflect over, in this case, the x-axis. And that's really what you want to memorize in terms of flipping and reflecting, is that if you change every x-coordinate to -x, and the way we write this in function notation, we take f of -x, right? That you're going to reflect over the y-axis. And what happens to the graph if we change every y-coordinate to a -y? Then we're going to reflect over the x-axis. Or flip, if flip is a better word for you. Reflecting and flipping are the same thing. What? You have totally done this before. Yeah, I mean, not in my class yet. We did a little reflecting, just looking at stuff, but we didn't officially. You know what we did? Yes, when we plugged it in, yeah, we did the algebraic test for symmetry. So it was similar because you were testing for symmetry. You're right. So you were testing to see if it was symmetric about the y-axis, symmetric about the origin, symmetric about the similar. Yeah, and we're going to kind of tie that together tomorrow. You're right. All right, so sketch the graph of g of x equals radical x. So there's my g of x. Then sketch the graph of g of -x. So what does that mean? It means that I'm changing all the x's to -x's. You can just join any of these groups. How are you? Good. I'm going to take my x's and switch them to -x's. So which axis should I flip over? Flip over? X or Y? Positive, that works. If I'm changing the sign of the x's, I flip over the y. It's always the opposite, right? Good. So if I flip it over the y-axis, it's going to go that way. Okay, so this is the graph of g of -x, right? Which really just looks like the square root of -x. And it just flips the other way. So let's talk about the domain and range of our original parent function. What's the domain of that original purple one? 0 to infinity. How about the range? 0 to infinity. Good. How about the domains of the -x ones? -infinity to 0. And the range? What's the range? Yeah, 0 to infinity. Right? And it would be inclusive. Okay. So what do we notice here? We notice that the range was not affected. Right? The range stayed the same? Well, the range obviously stays the same because I didn't do anything to y, right? The only thing I switched were my x's. My x's were switched, which means it makes sense, therefore, that my domains changed. Right? Your domain changed because you acted upon the x variable, right? So your domain's going to be different. All right, why don't you guys go ahead and try the second one? In this case, we've got x squared. Here's h of x equals x squared. Now they want you to take the negative and put it out in front of the function. Really what this means is this is taking a negative y, because h of x is the same as y. You guys agree, right? That's just function notation for the y variable. So I'm taking the opposite of y here. So when I take the opposite of y, which direction should I flip? Flip over x. Very good. Okay. So flip it upside down. And this graph is negative h of x, or negative x squared. And go ahead and fill in domain and range. And then check up here to see if you agree with me. So what did we notice here? Well, we noticed that our domain this time stayed the same, right? Because I didn't change any of my x values. However, my range changed. Because I was acting upon the y value, right? I switched the y value to the negative, so my range changed versus switching the x value, and your domain changes. Okay? All right, let's keep going. 2 down, 2 to go. We can do this. All right, yeah. Yep. No, you'd put it with the x because, see how it's in there with the parentheses inside the x, so I put it on the inside. This one's on the outside, so that's why I kind of put it out in front. Okay. If I had done negative x for this one, it would have to be in parentheses. Negative x quantity squared. Yep, good question. All right, cool. So now let's try to graph a bunch of these. And I'm going to let you guys kind of practice them. I want to talk about, well, this first one's easy. Go ahead and do the first one. How would it shift? How would you move it?
Yeah.
I like it to, again, draw my parent function on there. In this case, I would just move that vertex. Okay, so check your graph. That's good. Perfect. So if it's x squared, we just move our vertex and shift it over and up. Good? All right, so yeah, this one we got a lot going on, right? This next one. You've got negative x minus 2 plus 3. Okay, but I'm kind of confused in there because of all those negatives, right? And that gets a little tricky with, well, what do I do first? And how do I flip it? And where should I go with it? Okay. And so what I want, no, that's not what I wanted. Oh, that's all right. I'll find it. What you always want to do when you have something like this where the negative is right next to your x is the key here is you always have to factor out the negative. Okay? You always want to factor out the negative. Okay? So what does that mean? It means I'm going to take out the negative inside of here. So I still have the parentheses because it's still going to be squared. But I'm going to take out the negative. And then now that leaves me with x plus 2 on the inside, right? And then it's still that whole thing squared plus 3. I can't factor out the negative all the way out of the bigger parenthesis, right? But I just factor it out real quickly on the inside. Why do I do that? Because now it made a difference between going left or going right. If I hadn't factored it out, you'd have all thought we went to the right. But once we factor it out, we realize, oh, wait a second, we actually go to the left. Okay? Yeah, and so let's talk about what that negative does. That negative is acting on the x, because it's in the original, it's right next to x. So it's taking a negative x, which means it's going to flip over which axis? It's going to flip over the y-axis, exactly. So this negative x here means it's going to flip over the y-axis. Well, if I have a parabola, this is my parent function, and I tell it to flip over the y-axis, what happens? It just goes right on top of itself. Yes, nothing happens. A parabola already has y-axis symmetry. So if I flip it, then this side would flip on top of that one, that would flip on top of that one. So really you can't see this flip. Okay, nothing actually happens. So then I can now do my other moves, which this one means I want to go left 2, and then this one goes up 3. So I take my vertex, I go left 2, and up 3. This one does not flip upside down. Okay, it just moves over. If you have multiple stuff going on here, you've got a reflection, you've got a move to the right, move to the left, and up and down, you've got all this different stuff, you always write this big flip first. Always do your reflections first. Don't wait till the end to reflect because you will get the wrong answer. So flip first, and then I don't care. You can go left or right first, or then up and down after that. And the left and down, left and right, up and down doesn't matter the order, but flipping has to be first. Make sense? Okay, cool. So now let's try the rest of them. I'm going to kind of let you guys work a little to go through and start changing and transforming these next ones. Okay?